Okay, this is an example problem for a timber member in compression. Whenever you do that, you need Australian Standards AS 1720 nearby, so we've got that here. And we turn that to section 3.3, column design, and here are the formulas we need to use. I've also got my summary sheet with me. So we're going to design the member of a timber truss. It's in a roof truss, and in this particular example, it goes into compression when there is uplift, wind uplift on the roof. It's located in Brisbane, it's indoors, and the design load we have on it is 3 kilonewtons. The member is 2.8 meters long, and that's between the bolted end connections, and these bolt holes are 22 millimeter diameter. And we're going to make it out of a 190 by 35 machine graded pine 10. So we'll go to our equation, and the first thing we have to do is say that the NDC, which is the member capacity in compression, must be greater than N star. That's the load. And that comes from AS 1720 clause 3.3. So we'll go AS 1720 C 3.3.1.1. So we're going to reference all the code and other tables we do down the right hand side here. And we know that NDC then equals phi times K1, K4, K6, K12, F-C, and AC. And that's also that's equation 3.32. 3.32. Okay? And that's out of the code there, and that's also the same equation that we have in our summary sheet. So we have to go through and find each of those one by one. So let's start with the phi factor. Phi factor comes out of table 2.1. So we go to table 2.1, and this is the phi factor for calculating design capacity of structural members. Category 1, structural member for houses. No, it's not a house. Member other than a house, and it's in a building. It's not designed to fulfill post-disaster functions, so we're going to use here. And stress grade MGP 15, 17 or higher gives us 0.85. All other timbers and stress grades 0.7. So our phi factor is actually 0.7. Right. So phi equals 0.7, and we're going to reference table 2.1 for that. Alright, that's that one done. Now K1 factor. K1 factor is just a bit further. And we know that the K1 factor, because this is a member it's loaded mostly with wind. So wind in uplift, it's only a very short duration, it's actually 5 seconds. So the K1 factor is going to be 1.0. K1 equals 1.0. In the downforce, that calculation might be a little bit more complicated, but in this particular example, it's quite easy. There it is, table 2.3. K1, table 2.3. Next one is K4. K4 is table 2.5 or clause 2.4.2.3. K4 is a partial seasoning factor. And because we have seasoned timber, K4 should be the greater of that minus that. When we're indoors, we're using 1.0. For seasoned timber, generally K4 equals 1.0. It only gets less than that if we're dealing with humidity and other sort of problems like that. But K4 equals 1.0, and that's table 2.5. K6 is our temperature factor. K6 comes from clause 2.4.3. Oh, there it is there. Temperature factor, we are in Brisbane, but we're still south of 25 degrees south. So in fact, K6 equals 1.0, as it almost always does, unless you're far north Queensland, somewhere like that. And that is clause 2.4.3. Okay?